Alright, what we are doing today is just looking at the review sheet for your uh, congruent triangles test that's coming up, and this is just going to be essentially a virtual answer key showing you not only the answers for all the problems on this review, but also how you get all of those answers. So fast forward, I encourage you to the points of your review packet that you had trouble with, and that way you can go and look exactly at what you're doing and make sure we know how to solve these problems correctly. We're going to get right into it. The first 11 problems on here are pretty straightforward. It's, do you know what an equilateral triangle is? Okay, three congruent sides. Do you know what equiangular means? Okay, three congruent angles. And you can just get all these straight from your notes. Um, you can use diagrams to help you. So like for equiangular, if it helps you to draw something like that to explain it, that works very well. Especially something like number 9, exterior angle theorem. That would be kind of tough to fully explain. So maybe it would help if you were to draw a picture, draw an extended angle, call them angle 1, angle 2, angle 3, and angle 4. Then you can say angle 1 plus angle 2 equals angle 4, and that's what the exterior angles theorem is. Something like that, whatever it takes to help you answer your problem. I just need to be able to understand or know that you understand what we're talking about here. So just for other ones, scalene, 3 different side lengths. I mean, that's another one we know for sure. Third angles theorem we see a lot. If you have 2 congruent angles in a triangle, then that means that the third set must be the same. And again, we have lots of examples of all these from your notes. You should have the definitions in your notes, just whatever it takes to help you with all those. All right, let's move forward past those because those are going to be asked in a true-false type of questions tomorrow. So make sure you're able to understand what's going on here. You won't have to define every single one of these, but you need to know what they are. All right, looking at the next set, numbers 12 through 15, first thing it says is to solve for x, then classify the triangle. Well, let's start here with number 12. All of these, honestly, are triangle sum theorems. They are, you need to add all 3 angles up together and equal them to 180. So in this first one, we have 180 equals 4x plus 9 plus 2x plus 2 and then plus 7x minus 13. Simplify it, 180 equals 13x minus 2. That means that 182 equals 13x. And that means that in the end, you should get 14 is equal to x for that problem. That's the basic format for every single one of these. Number 13, same thing. 180 equals 100 plus 3x plus 2 plus 4x plus 1. When we solve that, you should end up getting that 7x equals 77, which means that x equals 11. I should have said here for number 1, after we find what x is, we need to go back and find out exactly what each angle measurement is. So in this case, when we go back and plug in 14 for x in every angle. This one right here becomes 30 degrees. The one up top becomes 65 degrees. And this one right here becomes 95 degrees. That means this is going to be an obtuse triangle. Same thing here with number 2. We're going to plug back in. Well, actually, we don't even need to plug back in, but we should find them anyway. This one is going to end up being 45 degrees. This one right here should end up being 35 degrees, but we already have a 100-degree angle. So this one also is an obtuse triangle. All right, looking down at the bottom. Well, I should be able to tell you immediately that this is going to be equiangular. And that's just because we have all 3 angles that are the same. 8x plus 8x plus 8x is equal to 180. That means that 24x is equal to 180. And you just divide both sides by 24. You should get x equals 7.5. Plug back in. They should all be 60 degrees. That's what an equiangular triangle is. And again, we have equiangular in the end. Okay, last one over here. We're going to add them all up again. You're going to end up with 20x is equal to 180. That's because you had 5x plus 2 plus 8x minus 10 plus 7x plus 8. All that is equal to 180. Simplify it. All the units go away, 20x equals 180, x equals 9. When you plug back in, you should get 47, 62, and 71 degrees. So this one should be acute triangle. Okay, move on to page number 2. Now we're doing the exterior angles theorem. You might still use a little bit of your regular, triangle sum theorem. You can do that immediately for number 1 if you wanted to. It's a little bit easier though. Exterior angles theorem. Y is the exterior angle. It's the sum of the two remote interior angles. So y equals 42 plus 73. That means y must equal 115 degrees. I can then find x because x and y make a linear pair, so x must equal 180 minus 115, and that means x equals 65 degrees. And then again, we need to classify our triangle here, and in this case, they're all acute angles. We're going to have an acute triangle. Looking at number 17, same thing, using exterior angles, x plus 82, the two remote interiors, must equal the exterior 103. Simplify that, solve it, x equals 21 degrees. You can then find y by doing, again, making a linear pair, so 180 minus 103, that means that y equals 77 degrees, and again we have an acute triangle as a result. Number 18, we're getting a little bit more tricky with the algebra right here. We need to set up the remote interior angles adding up to the exterior angle. So 20x minus 15 equals 5x plus 90. We're going to bring over the 5x to make it 15x. Minus 15 equals 90. Now bring the 15 over by adding it. 15x equals 105. That gives me, in the end, x should equal 7. I can plug back in at this point. This is what I need to do. Plug back in to find what these angles are. This one here becomes 35 degrees. This one up here will become 125 degrees. So now I can find my last angle y to be 180 minus 125, which equals 55 degrees. And as for what angle it is, well, we had a 90-degree angle. It doesn't look like it, but it is. So it's a 90-degree angle. This is a right triangle. All right, last one for this set. 68 is the exterior angle, must equal the remote interior angles, which are 3x plus 5, or 3x and 4x plus 5. So 68 equals 7x plus 5. Solve it, 63 equals 7x, which means that x equals 9. I need to plug back in. Well, when I plug back in, I would get 27 up top. I should get 36 plus 5 is 41 degrees down here. And to find out this last one, well, 68 plus what gives me 180? You're going to get, again, say 180 minus 68, so I should get 112 degrees for y. And that's why this is an obtuse triangle here. On to the last page. Oh, not yet. Forgive me, I forgot the bottom of that page. Probably need to do that first. Okay, all this is talking about is the third angles theorem. We have two sets of congruent angles. That means we can say the third set of angles are congruent, just set them equal to each other. 7x plus 22 equals 9x minus 4. To solve it, this is going to become 26 when we bring the 4 over. Subtract 7x on both sides, I get 2x. 13 equals x. So that's what x is, but we need to find the value of the angle. All we're going to do, plug it in. It doesn't matter which one, because they should be the same. I should get 113 degrees for this. For problem number 21, same thing. X squared plus 10 equals 2x squared minus 90. Subtract x squared from both sides, add 90 to both sides. I'll get 100 equals x squared. That means that x should equal plus or minus 10. Please don't forget the plus or minus part of that. When I plug in plus or minus 10, they're going to get squared anyway. So it's going to become 100 plus 10, so 110 degrees for both of these. Now we can move on to the back page. And the first one should be very easy. Name 3 pairs of congruent sides, 3 pairs of congruent angles. Well, just start by listing off the three angles that we have. Angle S, C, and O from the first one. S is first. We also have to put the T, which is first. They go together. The C goes with the I, and the O goes with the E. Just that simple. The sides, a little bit trickier. CO, or SC, I should say, and TI are the first ones that are in the same corresponding position. SC and TI. We can then do the same. CO and IE. So CO congruent to IE. And then the last one that's left is the ones on the outside. SO and TE. So SO congruent to TE. Notation-wise, make sure we know these congruent symbols here. Make sure we're calling these by segments because they are segments, so we need to have the segment markings over them. And then same thing over here with the angle markings. Make sure we have all of these as proper notation here because we want to make sure we're always using proper notation. Almost to the end. Problem number 23. Are the triangles congruent? If so, we're writing a congruent statement. So, on this first one, we have to look on all of these for that matter. Do we have 3 pairs of congruent sides and 3 pairs of congruent angles? In 23, we definitely do have all of that. So we're going to name this first triangle. It doesn't matter how we do it. I'm going to name it RMU. I'm going to name it that way just because it went from 1 angle marking to 2 to 3. So I need to do the same over here. From 1 angle marking, T, to 2, I, to the third, T. Number 24, it only looks like we have 1 congruent angle. However, we have in here vertical angles, so they must be congruent. And because of that, we can then say, by the third angles theorem, we have a third pair of angles that must be congruent then. So we do have 3 sides and 3 angles again. In this case, we're going to name our first triangle. It doesn't matter how. I'm going to name it SPE just to be different. So I went 3 to 1 to 2. And that means that this one needs to be R. I know it should not be R because we went from 3 to 1 to 2. So because we went 3 to 1 to 2, I should be going from L to R to E in this case. And as you're doing these, you should be checking your work and make sure. So ST and LR should then be the same. ST has 1 angle marking, LR has 1 angle marking. That's good. If I look at TE and RE, TE, RE, both have 2. Same thing I could say then for the last one, SE and LE. They must also have 3, and they do. So we're in good shape there. Number 25, we have 2 pairs of angles. We can say the third pair are congruent because of the third angles theorem. We have 2 pairs as well of congruent sides. Those ones with the blue markings and then these ones with the pink. We do not, though, have a third pair of sides. And there is no such thing as a third sides theorem, only a third angles theorem. So we're going to say, no, these are not congruent, and we just don't have enough information. We don't have enough info. We don't have enough sides, essentially. So we don't have enough info to say that these are congruent. They very well might be, but we don't know at this point. Okay, last one here. Very similar again. We have 2 angles. We can say the third one has to be congruent as well by the third angle theorem. So also then looking at the sides, we have 3 pairs of congruent sides. So we should be in very good shape, and in fact we are. So we can name it. I'm going to name the first one PEN, triangle PEN. So I went from 1 to 2 to 3. I need to do the same over here. N, S, T. PEN, N, S, T. All right, last set, and this should be hopefully wrapping things up for you. Hopefully you should be in good shape for your test now at this point. We're going to start by finding x. So we want to look, where is x? Well, x is right here. X is with angle S. Angle S, by our congruent statement, must be congruent to angle U. What do we know about U? Well, we don't know very much about U now, do we? So, let's see what else we can find out. Angle Y, maybe we'll start with Y, see what we can do. Y goes with, start with Y. Y goes with UI. UI goes with SO. So because of that, since UI and SO are the same, that means that they are the same, we can set them equal to each other. When we're going to solve, we're going to get 20 equals 2y. That means that y should equal 10. So that's how we're going to start this. Now, as for finding what these angles are, let's first look. If we know angle O is 41 degrees, O goes with I. So I can make this 41 degrees. Because of that, I can then say, well, I now know I have 41 degrees and 90 degrees. That means I can find what angle U is from there. 41 plus 90 gives me 131, which means that this last one should be 49 degrees. That's what angle U is. So I just found out 29, but also, since I know U and S must be the same, I now know that 49 equals 2x plus 10. I can solve that. 39 equals 2x, which means that 19.5 is what x would be here. 19.5 for that answer. Then the last part of this problem is to find side length UN. Well, there's UN. UN is similar, or I should say congruent, I'm sorry, to SC, which is over here. So those must be set equal to each other. So we have 8z minus 15 equals 5z minus 6. We're going to solve for this. 3z should equal 9. That means z equals 3. Now, from here, we don't want to know what z is. If I wanted to know what z is, I'd put it right in. But I don't. In this case, I want to know what un is. So I need to take this z equals 3 and plug it in. So plug in 8 times 3, which equals, this is what un equals, 8 times 3 minus 15. So 24 minus 15 for 9. So this value of un is 9. Well, there you have it. If you have questions, you know what to do. Ask. Hopefully, this has helped enlighten you. If you can do all the problems on here, you should be in great shape for your test. Have a great evening.